From mobile phones to cameras, computers, and now even cars, all the things you can't do without depend on tiny quantities of one rare metal to keep them powered up. Lithium is the crucial element in many rechargeable batteries. And one little backwater town sits right on top of the largest source of lithium in the USA. The trouble is, the lithium which is needed for your rechargeable batteries is dissolved in salt water and is sitting over 200 meters beneath the Nevada desert. So, how do they do it? Welcome to Silver Peak, Nevada. Population 379. It might not look like much, but this sleepy backwater town has a crucial role to play in the global communications industry. Because this is one of the few places in the US where lithium, a rare metal that can store electrical energy, is mined. The problem with lithium is that it's hard to find and even harder to get at. If you're lucky, you might find lithium in salt water or brine buried deep underground underneath dry lake beds. But the dry lake beds have to be in areas that have been volcanically active, which at least narrows down the areas where geologists like Melissa Jennings have to look.
Behind us is Red Mountain, which is believed to be one of the sources of the lithium. The fact that this valley is here, the fact that you had volcanic activity, you have plenty of water, you have great sun, those things all make Silver Peak unique.
Once you find somewhere that meets these exacting criteria, you've got to start digging, because all that lovely lithium-rich salt water is buried under hundreds of meters of sediment. And getting it to the surface is the responsibility of General Manager Joseph Dunn.
This pumping system goes down about 600 feet into the ground. We'll pump the brine to the surface and into our first pond.
The trouble with this lithium is that it's very, very wet, and they need pure dry powdered lithium to make batteries. So Joe pumps the brine into huge 16 square kilometer evaporation pools for the hot Nevada sun to do the hard work. Some of the water evaporates and salt from the brine crystallizes, leaving the lithium in a more concentrated solution. After 18 to 24 months in the bath, the lithium becomes up to 60 times more concentrated.
Right now I'm taking the pH of the pond and I'm measuring conductivity to see what concentration it's at and what saturation level it's at.
But just whiling away the time messing about in boats won't remove the lithium from the brine. So the salt water solution is pumped 5 kilometers to a processing plant for extraction. This maze of aluminium pipes and vats extracts every last ounce of lithium from the water. First, the brine is left to settle after its turbulent trip. Once it's been sieved and heated, it's ready for processing. In a giant blender, curiously known as the reactor, the brine is mixed with soda crystals to form a solid compound called lithium carbonate. A constant vacuum underneath the conveyor belt keeps every last gram of the valuable powder on while it's taken to be washed. Then it's sent to a rotary dryer to remove the last of the water. This nondescript milky white lithium powder could be made into medication for depression, but the latest generation SUV would look pretty glum if you tried to run it on this stuff. Turning it into a high-tech power source takes some technical wizardry. And when it comes to car batteries, the top wizards in the US can be found here, at the Johnson Controls Test Facility, Milwaukee, Wisconsin. Michael Andrew is top wizard.
The main activity in this facility is the design, development, and testing and evaluation of lithium-ion cells and batteries.
Lithium's great stuff for batteries because when you zap it with electricity, it holds on to the energy, becoming positively charged. If you wanted to release that energy, you just have to put it next to something negative and the charge will flow. Ordinary batteries can only do this trick once, but lithium's naturally positive disposition means you can charge it again and again. So to turn it into a battery, they've got to find a way to stick it next to something negative. First, the lithium is mixed with a solvent to turn it into a thick ink. Then it's poured into a large machine that resembles a high-tech printing press. But instead of paper, wafer-thin sheets of aluminium are coated with a thin film of the lithium ink. The thinner these sheets are, the more of them they can pack into a battery, making it more powerful. So they're squeezed through a giant mangle until they're thinner than a hair. When it comes to lithium-ion batteries, a flat battery is a powerful battery. And these are so flat, they can store 150 watt-hours of electricity in 1 kilogram of battery. That's 3 times more than an ordinary lead-acid car battery. Finally, the super-thin film is wound together with negatively charged copper in this winding machine to create one super-light, super-powerful battery cell. When each finished cell is charged, the ions will rush back and forth, creating 3.8 volts of energy. If you get enough of them, 84 should do, they can supply enough energy to power one of these. And as the technology improves, battery-powered cars like this SUV could make gas guzzlers history.
In 30 years of working in this business, it's truly exciting. We have a technology that is so clearly superior in terms of energy and power, so you can carry enough battery on board and drive almost exclusively on electric energy.
As long as one little town in the Sierra Nevada keeps the lithium coming.